Hello students, I am Mr. Nilesh Balasunalawade, Assistant Professor in Mathematics at Karmavir Bhaurav Patel College Vashi, which is Empowered Autonomous College. So today we are going to learn the concept correlation and regression analysis. So let us see the objectives of this correlation and regression analysis. So basic fact is that to understand the concept of correlation, use scatter diagram to visualize the relationship between two variables, compute the simple and rank correlation coefficient, and last one is test the significance. In this study, we are going to learn the Karl Pearson coefficient and Spearman's rank correlation coefficient, which is in correlation. In the introduction, correlation is a statistical measure that expresses the strength and direction in the relationship between two variables. Simply put, it tells us whether two things are related and how they move together. Main purpose is that it is used in the various fields such as finance, marketing, economics, and social sciences to analyze the trends and make the predictions. It helps us to identify the relationship between variables and decision making and make the predictions. Basically, there are three types of correlation. First one is positive correlation, when one variable is increased and other also increase, just like more you exercise, more calories you burn. Another is negative correlation, when one variable is increased and other is decreased. So let's see the example. The more you drive, less fuel remains in your tank. And last one is the no correlation, when there is a no relationship between the two variables, just like a color of your shirt and your exam score. And let us see the another example, which is a higher temperature and ice cream sales, which is positive correlation, because in the high temperature season ice cream sales are more, so it is positive correlation, and that means it is increase. And another example, let's see, increase the exercise and weight loss. This is the negative correlation example. Now you see this diagram, which directly says that there is a relationship between variable x and variable y. For example, this relationship exists between the income and expenditure. In the scatter diagram, if the relationship is confirmed within the two variables, then it is called a simple correlation. In the first diagram, we will see that if this value of r is strictly greater than 0, then this means a positive correlation. In the second diagram, you see that negative r strictly less than 0, which is a negative correlation. And third diagram, if r is equal to 0, that means there is a no relation between any. In our convenience, let us see the perfect positive correlation. In that case, r becomes strictly 1, and perfect negative correlation. In that case, r is nothing but the minus 1. Now we are going to take example number 1. In this particular example, let us see in the columns years, and next one is advertisement expenses, which is x, and sales, which is denoted by y. In 1995, advertisement expenses is 6 and sales is 60. Similar fashion, we will just see that in 2004 there is advertisement expenses is 0.5 and sales is 10. In the diagram, in the right side diagram, let us see that diagram indicates that the advertising expenditure and sales seems to be linearly positive. That means which is positive correlation. That means the quantitative measure of the strength of the relationship between two variables is called the correlation coefficient, and this is the linear correlation coefficient. Basically, there are three types of method to compute the correlation coefficient. First one is scatter diagram, which is already seen. This is a graphical representation of data points. Second one is Karl Pearson correlation coefficient, which is mathematical method to measure the linear relationship between the variables. And third one is Spearman's rank correlation coefficient. It is used when the dealing with the rank and ordinal. In the Karl Pearson correlation coefficient small r, which is denoted by small r, and as summation x minus x bar y minus y bar upon n upon sigma x sigma y, which is simplified formula, as r is nothing but the summation xy upon summation square root summation x square root summation y square. And probably this formula is used when x bar and y bar, that means mean of x and mean of y, becomes the integers. And rest of the cases you are going to use the second formula, which is r is nothing but the summation xy minus summation x summation y upon n divided by under root x square minus summation x square upon n, and similarly for the y. Let us see the example. In the column number 1, advertisement expenditure, which is denoted by x. Second column sales, which is denoted by y. And we are going to compute the column number 3, which is xy, then x square and y square in the rupees. advertisement values are 6, 5, 5, 4, 3, 2, 2, 1.5, 1.0, 0.5, and summation of that x is 30. Similarly, summation of y is 326, and so on. Summation of xy is 1288.5, summation x square is 122.50, and summation y square is nothing but the 13696. Now we are going to use the second formula because all the values are not in the integers, so we are going to use the second formula, which is r is nothing but the summation xy minus summation x summation y upon n, and rest of the terms are same as it is as we discussed the formula earlier. So we are going to put these values in that particular formula, and we know that students we are going to use the calculator also. So numerator value becomes 310.5 and denominator value becomes 315.7. So it is very easy to calculate by the use of calculator. So we are getting the value 0.9835. That means the calculated coefficient of correlation shows that there is a high degree association between sales and advertisement expenditure. Now, another method is Spearman's rank correlation coefficient. Now we will see the formula of this method, capital R, which is strictly denoted by capital R and nothing but the 1 minus 6 summation d square upon n cube minus n, and where n is nothing but the number of pairs of ranks, and summation d square is nothing but the squares of differences between the rank of two variables. Now we are going to see the example of Spearman's rank correlation coefficient. The salesmen employed by the company were given monthly training, and at the end of training they conducted a test on 10 sample basis. Let us see this example. First row becomes salesman, second one is rank, which is denoted by x, and third one is ranks of sale performance, which is y. Let us see the values already seen here. So in that particular table, we are going to calculate the capital R, which is Spearman's rank correlation coefficient. But in capital R, we require the terms summation d square, n cube, and n terms. So let us take these values: salesmen's in column number 1, rank scored in the training, which is x already given, rank secured on the sales y, which is also given, and we are going to calculate the difference between these two ranks. So capital D is nothing but the x minus y. So first value is 1, second one is minus 2, up to so on. Last value becomes a minus 1. And we are going to calculate the summation d square, which is a 24. And we are going to put these values in the formula. So we get the value 0.855. That means we can say that there is a high degree positive correlation between the training and sales performance of the salesman.
Thank you so much for watching this video.